Hello, I'm Sandeep. We are discussing the digital electronics question paper from the latest examination of BTech branches, and we have reached part B, and we are going to answer this time question second, which is of 4 marks. To answer this question, first let us build up a basic understanding what is sum of products and products of some function. So basically, if we have two input variables a and b, they can take these different combinations of input values. If we have inputs off or on, no other possible combination exists. Now let us take a random function. Let us take AND logic function. In AND logic function, the output is always off, and when a and b both are 1, then only the output is 1. This is represented by these input combinations are represented by minterms. So summation is used as a symbol to represent minterm. This is m0 minterm. The code is represented uniquely by this. Then we have m1, m2 and m3. So these are the minterms. And how are they written? Minterms are written by putting variables instead of these numbers, and the 0 goes like this, and ones go like this, uncomplemented. So these can be written in minterm forms like this. So these are the minterms. Now why I have written the minterms? We can write this function. This is a function, okay? This is separate thing. These are inputs. So let us show you what actually we mean. We mean that a is input, b is input, then the output will be AND logic, and this will happen that if both are zeros, it will give you a 1 at the output. So this tabular form is represented here using a symbol, and then we can populate it in K-map also. So K-map, okay, first we will populate it in K-map, and then we will understand what is sum of products and product of sums. So we have this general template of K-map, and now let us populate this function. When ab is 0 0, a is 0, b is 0, the function does not exist. Give 1 when 0 1, the a is 0 1 also not possible. Only when a and b are both equal to 1, then only the function gives an output. So this truth table can be represented in K-map also. Now if we write the function that is indicated, then we write it as ab. This is Boolean algebra, this is K-map, and this is truth table, and this is minterm listing. Okay, all the minterms are these, and out of this only this minterm is part of this function, so that's why I've written this. Now this is called sum of products representation. This is sum of products representation. So basically function is this. Now what is the complement of a function, and then again complement of a function? It is equal to f. Okay, and let us start writing this. So f is what? Which minterm is f? Which minterm is f? It is m3. So we can write like this also. You can write the same function, as a minterm also. Okay, so what is complement of f? These are all minterms which are other than m3. And what will be then complement of all this? It will be m3. So what we can do is we can algebraically get this thing written and get the product of sums function. See, what we are doing is we are taking f dash. What is f dash? F dash is all these except the part of this function. What are all these? These are a complement, b complement, this minterm, this minterm, and this minterm is complement function, which is not a part of this function. So f dash is equals to a complement b complement, or a complement b, or ab complement. I've written all this, copied from here, all the complement function. Now what is the complement of this? This is function itself. Now let us take the complement of all of this. So what will we write? We will write f complement first, which is this, and take whole complement. So this whole complement will give us f again. Now let us solve this. Let us continue solving here. So f becomes a or with b, a or with b bar, a bar or with b, and this is product of sums function. So function can be written as a b also. Function can be written as a b also, and it can also be written as a or b, a or b bar, a bar or bb. So this is sum of products representation, and this is product of sums representation. You can repeat the same exercise for OR gate logic also, and get an understanding what has been done. So a brief review will be that you have a truth table of AND gate, write all the minterms. This is the AND gate. The minterms can be represented in a K-map, which are the part of the function, not part of this function. Then this function can be written like this. Then the complement of the complement is nothing but function itself, which is represented as minterm. Let us start by populating this, which is these minterms, then take complement, which is that minterm. So let us write the Boolean expression of f complement, which is this, then take the whole complement, which is this, and this is essentially same function. So this function can be represented either like this or like this. So both are having same Boolean expression but expressed in a different way, and the way they are expressed, they are named as product of sums and sum of products. So there would be sum if there were more minterms here. So that's why I want you to repeat the same exercise for a OR logic also, so that you can differentiate between product of sums and sums of product. Now how will you directly answer if somebody asks you write this function in product of sums form? What you will do is you will directly take these and write the max terms. Now what are max terms? Max terms are represented by a pi symbol and a capital letter. Okay, let me bring the camera closer again. So max terms will be capital letters, and this time max terms will be written like this. Let me write max terms here. Max terms will be written for a bar, it will be a uncomplemented and a sum in between, and b. For this it will be a or with b bar. For this it will be a bar or with b, and for this it will be a bar or with b bar. So these are the max terms, these are the min terms. So what you do is directly, if you want to write product of sums function, you pick the non-participants and copy the max terms of it. So let us do that. So this is not a part of the function, so we'll have this in our function. Then this is also not a part, we will write this as a function, and then this is also not a part, so we will write this as a function. So we have directly found the product of sums form from the sum of products form for AND gate function. We'll confirm our answer by checking out. This is same as this one, so either you can get directly from the truth table, or you can simplify by reasoning and get the product of sums form. Now let us start answering the question. The question that we had is that we want standard product of sums form for this. So let me solve it for you. Let us have A, B and C. Let us have all possible combinations. Now let us write the max terms. First of all, let us write the function. Function is for minterm 0. So let us number them also. This is the 0th, this is the first, the second, third, fourth binary code, fifth binary code, sixth binary code and seventh binary code. Now which are the part of functions? 1 is a part of function, 4 is a part of function, 5 is a part of function, 6 is a part of function, 7 is a part of function, and these are not functions included in function. Now you can directly write the max terms, A or with B or with C. Max terms are written in capitals and uncomplimented for zeros. Then this is also there, not a part of function. A or with B bar or with C. Again this one also part of function, A or with B bar or with C bar. So in standard product of sums which we have complete max terms, we will write the answer as A or with B or with C, and then we'll write this one A or with B or with C, and then we'll write this one A or with B. Rather than explaining, I am straight away writing the answer because I have already given the explanation in two different ways before, and this is your answer. So the answer to the question, this question is, in product of sums format this function will look like this. And if you want to verify that you are right, we can check that these minterms will be there when we evaluate this and get it into standard sum of products. So I hope this helps. If I am wrong, you can correct yourself by getting this understanding. When you develop this understanding, then you will easily and directly write answers. You can just quote a sample answer would be this, that you quote that max terms are written like this and the function is this, functions complement is this part, these terms, and complement of that is this, and this is product of sums representation. Thank you.